where people see thought leaders bringing up the latest topics and trends, particularly in composites, industry, and advanced materials. We are seeing people working on sustainability and the future. To this end, welcome to our 2025 episodes of Composites 360 on tour. We bring you the brightest minds, influencers, and subject matter on your screen. With live panels at subject exhibitions, we are here to serve you with the latest content that is available in this industry. Whether it is aerospace, automotive, whether these are regional events like here in Istanbul, in Krakow, Poland, in Paris, France, or Germany, it could be also in Italy, we are here to cover those events in order to bring you the most pressing ideas and the most creative ideas to create sustainability and connect the global composites world. We invite you to join our Composites 360 on tour. I bring you the brightest, the best, and the farthest topics on LinkedIn.
Ilkay Eskisolu, Composites 360 on tour with Composites Lounge weekly on LinkedIn, YouTube, and your preferred podcasts.
So wonderful. Good morning, dear LinkedIn community, Composites Lounge members, and Composites enthusiasts out there. We are live, and I'm proud to introduce you the first edition of our Composites Lounge Engineering Talks. Before I get my guests here on the screen, let me introduce you a bit about Composites Lounge and what we are going to do with the engineering talks. So Composites Lounge is a group here on LinkedIn. You see here LinkedIn. I'm also a LinkedIn learning instructor, LinkedIn learning coach. And LinkedIn is a great tool in order to be digital visible, to provide your reputation, PR, and marketing. And we have also this Composites Lounge group here on LinkedIn, which is a solely online group, and we are welcome to join our page, to follow our page, and to join our group. And what we are doing with Composites Lounge is we are talking about technologies, about innovation and sustainability. And of course, we are networking, not only in the Composites Lounge in the digital world, but also in the real world. And I'm seeing a lot of experts out there, and I've thought, let's get these experts in a format which is called the Engineering Talks. And the Engineering Talks, as it says by name, are very highly technical and engineering style topics that we are going to talk. So today we will talk about the engineering part, the reinventing in innovation, or reinventing aviation by quality and efficiency. And let me greet for this purpose, first of all, our partner who is partnered up with Composites Lounge, which is Alexander Chaloupka. Alexander, he is the CTO of sensXPERT, a expert in AI and sensor technology. Thank you, Alexander, for bringing us this show.
Thank you, Ilkay. Thank you for the kind introduction. And
You're
I'm
welcome.
really curious to see all the content we have collected for this day. And I'm looking forward to hear all the insights from our two guests.
Yes. So, and our guests today are, let me start with Christoph Lieske. Christoph, I've met Christoph at DLR Braunschweig on their Empower AX and Science Days. That was in September, end of September, and he held a great, very inspirational keynote talk about sustainable fibers. Welcome, Christoph, to our show.
Welcome, Ilkay. Thank you for the invitation. Moin, Alexander.
Yes.
Good morning.
Last but not least in our group is Michael Kupke, and he is right now tuned in from Augsburg. So you see we have Munich, we have Augsburg, we have Hamburg, and we have Bayreuth, myself here. So the trailer said today from Istanbul, but we are not in Istanbul. We are today in Germany, but it may be that in the future we will be streaming from elsewhere in the world. Composites Lounge has originated in the DACH region, German-speaking region, but of course we are internationally connected. Yes, so before I dive now into the discussion, and I would like to start with Christoph about the fibers, the natural fibers that Lufthansa Technik is right now probing and testing and gathering data on. Later then we will speak with Michael about the process technologies, and Alexander, of course, about the process quality and inspection type of topics. So we've really prepared a lot of added value today for you guys. And if you are now in this LinkedIn Live and watching us our lives, please, by all means, leave a comment so we can see the spread of this LinkedIn Live. From where are you tuning in right now? This is what we want to see, of course. How is our reach on the globe? We have invited many people, and we have some over 170 registered participants here. I know that not everybody can attend live because everyone has to do their work, of course, but you can watch this anytime you want in replay. And from this replay, there is also a parallel stream right now on YouTube, if you want to watch it on YouTube for any reason. And soon we will have this also as an audio podcast. So this is the first edition with Aviation. And let me start just after this short break with Christoph Liesen. So, Christoph, now here we are after DLR, your presentation and the wonderful part that you've shown to us. But before we dive into the topics, now you have a very exciting job at Lufthansa Technik. And actually, dear community, we have discussed with Christoph how can he attend this LinkedIn Live, because of course he's in a very dynamic environment. And he has to conduct tests, and these are sometimes short notice. Can you explain us, Christoph, what have you experienced the last 24 hours?
Yes, my plan was actually to fly yesterday from Munich to Montreal for some to take some test data during flight and in Montreal. So yesterday I went to the aircraft, went on boarded, installed all my test equipment, started the testing, and just after the gate was closed and the bridge to the aircraft was removed, my colleague told me, jump off the aircraft, it's not working, it's wasted time. So I had to talk to the crew, and they allowed me to leave the aircraft. So I was very lucky. They brought back the bridge to the aircraft, so I was allowed to leave with all my equipment. So I'm not returned today because actually the plan was to fly all the way to Montreal and back with the same aircraft, to just leave shortly for immigrations. Now I had to stop it. I'm luckily back in Hamburg. Actually, I was supposed to be in Munich by now, I think. So that was the old plan after 24 hours of flying. So yeah, I have now some more time, and I'm more relaxed than spending all night in an aircraft. So it was quite a funny story. And I had a very nice crew. They really helped me leave the aircraft. They was really nice of them. With yeah. So yeah, it's quite interesting sometimes to research, and that's my job here at Lufthansa Technik.
Yeah, the fascinating part is, did I understand correctly that you had to talk to the pilots to bring you back to the finger, they call it, to the gang? They just stopped on the apron.
No, they didn't stop on the apron. We were still standing at our parking positions where all the passengers boarded, and the finger was already gone. So they called ground operations, and they brought back the finger, so I was able to leave. The claw was already dosed, but they reopened the door for me to leave the aircraft.
I can imagine the last wording is always all doors in flight. I think that's
Yes.
the last words. So these were already spoken, and then you decided to go off the plane, right?
Yeah, yes, that was
Sort
the
of,
point.
sort of,
Sort of the
sort of.
point where I left.
Yeah,
Yes.
yeah. So I can imagine what kind of eye looks you had from the passengers still waiting to take off, and you had to go out.
Yeah. Some people were looking quite funny. Not too many because I was
Not
front of the
amused.
aircraft.
Not amused.
It took 2 minutes, so it wasn't a big of a problem. But yeah, it was very fortunate for me.
Yeah.
So now we have to find out what went wrong and change our plans. That's the next step for this afternoon.
Yeah.
And then find out the next flight I have to take.
Yes. So this is the reality of R&D. Things have
Yes.
to be organized in a way that you can collect quality data, that you can work with the data. And this is also a huge topic today. So Christoph, just in a nutshell, so this was a great entrance into our topics. So what is your role at Lufthansa Technik? Just tell us about and how did you come to this role? How did you study this role, or have you been experienced this role?
No, I'm quite long at Lufthansa Technik. Actually, I started as an apprentice for electronics and spent some years here as electrician and repaired navigation systems, communication systems, and panels for the aircraft. During that time, I studied lightweight at HAW in Hamburg. And when I finished, I became an engineer with the studies. And the first 8 years as engineer, I worked for the tooling shop or tooling sites. So if you want to repair components in an aircraft, you need to have all the equipment you need for that. Next to personal and material requirements and organizational requirements, you need a lot of tooling. And my job was to design and aggregate these tools. So basically from buying a hammer to specification of full test bench, fully automated. I built them my own, the test benches, programmed on them on my own. I also just wrote a specification and told someone else to do it for me, depending on what kind of technology and how far it went. Most of the times I spent actually with our toilet shop, with our pneumatic shops. And that's so where my most expertise went. And 3 years ago, I found a new position in here, research. My first project was it's so-called LUFO, Luftfahrtforschung, which is sponsored by the German government. And they have some projects and you can apply for them. And that's basically the last 3 years, my job, to apply for research projects, work with those research projects, find the right topics. Yeah, and from lead to basically basic work, everything is with it. It's my decision how deep I go in it. Yeah, very interesting.
Let me ask you about Lufthansa Technik itself. So, how large is Lufthansa Technik? I think you are based in Hamburg, and let me ask you: is there a specific reason why Lufthansa, as an airline, has decided to also go on the technical side of airplanes into R&D and develop parts, for instance, and even produce parts?
Yeah, so Lufthansa Technik is a 100% daughter of the Lufthansa Group. And basically we are founded, I think we have now 25 years as own company, was founded as a service partner for the Lufthansa to repair all the aircraft. So an aircraft, after landing, you have to do some checks. You have to look into the aircraft if everything is all right already for the next flight. And that was the main reason for Lufthansa Technik to be founded as an own company. Then we went into the repair of those components. You can take a lot of components just out of the aircraft, put in the new components, the aircraft can fly, and we repair that in our shops in Hamburg. Right now, I think we have around about 25,000 people working for Lufthansa Technik worldwide. So the main station is Hamburg, is here in Hamburg with 8,000 people, and the rest is working worldwide on all stations. Yeah, so that was the reason. And one thing we have now here is we are also having our own design operations or a design company. We are allowed to design components for aircrafts. We also have our own production facilities, so we are also allowed to build components for aircrafts, mainly coming out of the requirements from the airlines. We want a new cabin in our aircraft. Please put it in Lufthansa Technik. So we started getting our design organization, and at some point we found out that we are quite good in designing to building these components on our own. So now we are also doing this, but the main focus is not for the commercial airlines. With a production side is more on the business side. So business jets right now.
Christoph, I fly since I am 2 or 3 years old, and the very first flight I remember, and I remember maybe I've flown before that, but the one I remember was a Hamburg, Nuremberg, Istanbul, these legs. So we entered the plane, Lufthansa plane, in Nuremberg to fly to Istanbul, and one of the recurring announcement is always: Und Leuchtstreifen am Boden führen Sie zu den Notausgängen. Let me try this in English. So on the floor, the lightning will lead you to the emergency doors or something like that. Now, I'm saying this because Lufthansa Technik is the inventor of the non-lighting, right?
Yes, the floor pass marking is the correct word. Our product is called Guide You, and this floor pass marking is basically standard on every Airbus aircraft, and we are building it. We have our company, daughter of us, they are building it, and we are giving the certificates to it, and it's made here in Hamburg, and it's basically on every Airbus aircraft. It's our most known product. Who never knows it's from Lufthansa Technik.
Yeah. And this is the reason why I'm saying this, because everyone, when they see Lufthansa Technik, probably know Lufthansa Technik from the maintenance side and things like that. But you are actually a producer of components, and this is one of your highlight products. Okay, wonderful, Christoph. So our topic today is mainly composites, and you've shown me a part during our Braunschweig meeting after your keynote. Can you explain us what this part is about? What is the novelty of it, the innovation? If you can talk about it. If not, we have to, of course, sometimes, things are secret, and I understand that. But just reveal us, what is the mission of this part? What is the function and the purpose of that part?
So at Lufthansa Technik, we are looking also in some materials we can use for our engineering. And one thing we looked in the last few years is aeroflux, so replacing glass fiber and carbon fiber in the cabin, mainly through regrowing natural fibers. And we are focusing right now on flux fiber, and it's quite interesting, quite some challenges to solve with, as natural fibers have not the same properties as industrial fibers. So we are right now in the process of making, with some partners together, a usable product for us out of it. So that's where we stand right now.
The flux fibers. Now, in the beginning, I'm brutally honest with you. When I heard about flux fibers, not from you, but general in the market, and that's years ago, I was always thinking, wow, can flux fibers or hemp fibers or all these naturally grown fibers, can they really be a technical solution? And your keynote speech opened to me a totally different view on these fibers. As far as I remember, you've mentioned that you could use, of course, in all the parts, carbon fibers, but you are looking for of course, lightweight features, and carbon are certainly the best of the best fiber in terms of lightweight features, in conjunction with aerospace. And in aerospace, of course, planes have to be lightweight by default. But you have this notion at Lufthansa to say, okay, lightweight is one feature, but we want, of course, the sustainability part there. why did you decide then to compare the flux fibers with the carbon fibers? And you know that flux fibers may be not as lightweight as carbon fibers. Why did you then choose flux fibers anyway, although they may be a little heavier than carbon fibers?
We looked into this topic because carbon fibers are made out of what was the word for it? It's not a natural grown fiber. It's made out of oil basically, and has quite a big CO2 equivalency. And we try to look also into topics where we have where we get the CO2 equivalency footprint down. And natural grown fibers have this functionality. They take CO2 out of the atmosphere. We can use it then, and when we actually not recycle them, but just burn them, that would be the worst case. We are still more or less CO2 equal neutral to it. And this was one point we looked at it. The main challenge is, even though the CO2 equivalence of the product itself is low, the lifetime of this product is the most spending time, or the most the time that counts most. So we have to find the sweet spot where we can replace actual products with something that's lighter, so we don't burn as much fuel, but also be being better in the CO2 equivalency. So this is a very this is the big challenge about it. We could go to carbon fiber and would be also very lighter, but carbon fiber is also expensive. And we try to find the sweet spot where we have a good product, which is lighter than the standard product, and is not as expensive as a full product out of carbon fiber. And that's the challenge where we work on right now. Ikai, I can't hear you any longer.
Yeah, okay, sorry, that was the mic, which I'm muting for our podcast guests so that they don't have any noises around. Great that you reminded me. So we have a question from Christoph to Christoph. That's funny. So Christoph Zunke is asking, what was the main reason to exchange or to change from glass to natural fibers? So you've explained this from carbon to glass, is from carbon to natural fibers. Is there also glass? Is glass still a topic in the aerospace?
Also glass fiber is one of the standard products used in the cabin of an aircraft. Has a very long standing in the cabin. We compared the CO2 equivalency of glass fiber, standard glass fibers for the cabin with Aeroflux. And it's quite hard to compare because right now flux fibers and matrix to it is still not on industrial production level. So the CO2 equivalency is higher than expected, actually, but not as high as with glass fiber if you just look on the product itself. So yeah, the hope is to get it lower if you have more industrialized production processes on it. So get it more lowered, almost to zero. You won't get, I don't think we will have a net zero on a CO2 equivalency on a product there, but we're trying to get as close as possible to it.
Okay, wonderful. Now, my next question to you is, Christoph, the part that you've shown me was an interior cabin part.
Yes.
Now, with composites, we have this a little challenge that most of our parts are invisible. They are somewhere in the engine, in the frame, in the nacelle, not visible to the public. So this part is actually also not visible to the public because you see only the white interior wall. But let me ask you, what is the challenge when you develop something for the cabin? What challenges do you have to master as a R&D?
One of the main challenges for the cabin is there are quite strict requirements regarding flammability, toxicity. So if anything starts burning inside an aircraft cabin, That's not good, obviously. So there are some requirements how much heat a burning component is allowed to apply to the area. So this would be a flammability test and heat release test we have to conduct. And there's very strict levels we have to keep. Also, there are some toxicity levels. So if it's burning, there shouldn't be too much toxic gas getting out of the component, because there are a lot of people in the cabin, and we want to keep the so they shouldn't be toxified there or burnt there. So that is the main challenge. And as you can think, with industrial fiber, it's easier to have a straight or equal level to the fiber. With natural fibers, the fiber is not straight, the same properties all over the fiber. So it changes because it's grown. And these changes in the fiber are the challenges to neutralize that, to have to keep our requirements straight and be able to work with it. So this is the main challenge we are working on right now, to coming on one level, a reproducible level, where we always have the same results.
The evacuation of a plane has to take place within 90 seconds. We remember, maybe luckily, maybe sadly, this crash of Japan Airlines, of the was it the Dreamliner or was it the A350? I'm not sure on that one, but it was a carbon based one of the lightweight products right now, and all passengers survived because within 90 seconds everyone was evacuated. Now 90 seconds is not so much time. I'm just asking myself, is this 90 seconds rule, is this really posing a challenge to materials? Because if it starts burning, 90 seconds is not a lot of time. So you can be actually relaxed, in my view. Is it not?
I never compared evacuation times to the flammability requirements.
Yeah.
The 90 seconds is actually quite a challenge. I don't think it's from the lightweight spec or the component size. It's more from the design of the cabin, how you place certain objects. A few years ago, I actually those tests I conducted quite regularly for certification. And a few years ago, I volunteered for one of those tests. It was quite interesting. I spent the full day at Airbus and did this test once. Very interesting. If you ever have the chance to do it. Jumping out of an aircraft using the slide is not in an emergency, but on that side was quite interesting.
It was fun to do it.
It was quite fun to do it. They put a lot of stuff into the cabin, which is normally not lying on the ground, but if you have an emergency, probably might be around.
Yeah.
It was dark, and it's quite a challenge to have, everything in the right place, so that if you have all the people run out of the aircraft and jump onto the slides, that this is going on in 90 seconds. And I think I don't know how how these 90 seconds compare to the flammability test, how they are connected to each other completely. It's more like something starts burning. You have just like two or three fire extinguisher in range. You try to extinguish the fire. That normally works, but if it's a fire, the source of fire was closed down, everything else shouldn't be burning any longer. So this is one of the requirements. So you put a flame under it, it starts burning, and you take the flame away, and it's not allowed to burn any longer. It's one requirement, and the heat compares to it. So if you have a certain, below a level of heat that is released by the fire, it's easier to extinguish the fire. So it's not going to make a whole lot of flames, and nobody can do anything against it. That's the main reason in the cabin. And there's different requirements for the cabin and the aircraft structure. So if obviously cabin, there are more sources or possibilities for people to bring burning sources to. So the requirements differ a lot. And don't ask me for the requirements for the
Okay.
for the
No,
structure.
just came
Because,
to my mind.
that's not
Just
my-
came to my mind because it was in the public, of course, awareness that composites actually ensured that all these people survived. Yeah. The sad part of it was there was a rescue plane, I think, at the runway that
Yeah, it
was
was a-
overrun then. But the main plane of Japan Airlines was completely evacuated. All people survived, and Composites was a big contributor that everyone survived. Yeah.
Okay, I didn't read the report on.
Yeah. I will tag this. I've made this also a topic in the Composites Launch in an post. It's very, very interesting. Anyways, Christoph, I will come back to you in a moment, and we will talk later with you about the challenges with grown fibers. In the meantime, let me greet now Michael Kupke. So, Michael, welcome to our Composites Lounge Engineering Talks. You are tuning in right now from Augsburg, DLR Augsburg. So, from my community, Composites Lounge community, I was very close to that building where Michael is right now. In 2022, we had a Composites Lounge conference at the TZA, the Technology Zentrum Augsburg, under the host. The host was Sven Blank and Composites United. So we had a very interesting part there. And nice to be back in Augsburg, although it's virtually. Michael, maybe you can explain us. There's a big background. What is seen on the background of where you are there?
Yeah, this is our shop floor. So we have a near industrial environment that you need if you go up to TRL 6, technology readiness level 6 for lightweight structures. Then you need a near industrial environment. You need to show the scalability of a technology up to full scale parts, and you have to show the reproducibility of your process results. And this is the reason why we have such a flexible, large-scale facilities here to develop automated production technologies.
It's a very huge building, I understand. So I'm assuming you have several of these areas, or is this the only one?
No, yeah, we have several smaller robotic cells, and there we do the pre-development of several steps we need in production, including NDT, for example. And we have one large robotic cell, which is 30 meters in length, 15 meters in width, and about 6.5 meters in height, where we can put all these production steps together to have a production line of whatever. Yeah.
Okay. Now that we know where we are right now in your backdrop, let's talk about Michael. Michael, how have you come to this composite world? What's your history and what is your role right now at DLR in Augsburg?
Okay, so I started studying composites. Well, I don't remember the year, but when I was a student, I decided I was a student of mechanical engineering, and I decided to specialize in material science. And within material science, composites somehow struck me, and I dived into this. I also made my PhD then in Hamburg at the Technical University, where I developed a material for Airbus, a composite material. And after that, I joined Airbus in 2001. Was there in different positions, started in R&T for composite fuselage structure technology and the pre-development and R&T. was then at the VTP, then came back to the fuselage technologies, and in the end at Airbus. Before I left Airbus, I was responsible for the composite structure for the typical fuselage for the next aircraft. And then I joined the DLR here in Augsburg. And there I'm heading the Center for Lightweight Production Technology, until now. So a long time.
So it's a long time, many milestones in your career. Congratulations on that. So what fascinates you as an engineer with composites? What is that? What is that material? Why is that so attractive to you?
Well, you have the opportunity to tailor your material to what you need. And this gives you a lot of opportunities of integration of several functions, for example, electric conductivity or an insulation function, depending on your fibers, if you use carbon or glass, for example. And the anisotropic behavior of carbon fibers gives you the opportunity to tailor the material to what you need for your loads environment. And this is very fascinating. You can also combine deformation with or loads with deformations. Can save a lot of systems there because you can make intelligent materials from it. So the opportunities are great, and we are still more or less at the beginning to discover what we can do with composite materials.
Mm-hmm. So in a sense, you like can we say design freedom, that you really look at the problem, the design challenge you have, and then you start thinking, okay, what matrix can I take? What fiber shall I use? And what process do I take? Yeah.
Exactly. And what design is best for this.
Yeah, absolutely. So that's fantastic. I always hear lightweight, I always hear corrosion, but you come, it's the first time actually that someone says to me, I like the design freedom, that I can really combine the materials and the processes and think in a system. Yeah, and that's really the beauty of composites, and that's also why I think it appears very complex. But once you understand the composites feature, the behavior of the different kinds of fibers and matrices and designs, then you can really make some specific solutions. Michael, let me ask you, do you have a very exotic application where you think you have used the design freedom to build up something? And I'm not looking for something that goes in high volume. It could be also only one part which you think this is very representative of what I'm saying here.
Mm-hmm. Yeah, there's one example from an R&D project that I was leading when I was at Airbus at that time, together with EADS military and also with the German Aerospace Center. And one thing was the main landing gear bay bulkhead, which is today, these are metallic parts shaped like this, and the main landing gear is underneath this. And yeah, we try to figure out how would we build it in composites. And there we made a model, a wire model, very small, like this size, of the frame around the main landing gear bay pressure bulkhead, and put it into a soap water. And then you get this soap bubble skin. Yeah? And that means you have the minimum energy state. Minimum energy means minimum surface area. Minimum surface area means minimum material. That means minimum weight, and it means minimum cost. And from there, from this shape, we designed a main landing gear bay bulkhead which is perfectly designed for carbon fibers. So it's really a design for fiber architecture. And another demonstrator we have built recently, it was a full-scale thermoplastic fuselage. It was a half fuselage, 8 meters in length, horizontally cut, 4 meters in diameter, so very similar to A320 size. And we made a fully thermoplastic matrix fuselage structure there. And there we could show all the opportunities that you would have with thermoplastic matrix materials, with which is, for example, welding, or in situ automated fiber placement, where you can skip the vacuum bagging and the autoclave process and so on. So these are two quite interesting things that we did.
Yeah, totally relatable. The thing is, these bulkheads, they're flying around the world all the time, a complete life, like 30 years, 40 years. And you want to be, of course, so much lightweight that you do not produce, because of this part, a lot of CO2. And
Exactly.
on the other hand, you have still mechanical properties that have to be matched. And this is excellent, yeah. So that you could find a solution that is both good for the environment, but also good for the safety and the proper functioning of the plane. Excellent examples. Thank you, Michael, for this. Now, let me ask you about the process, the automatization. Now, planes, I don't know, Airbus has maybe 400 planes in a year. You cannot compare a plane production, for example, with automotive. Volkswagen Golf, maybe in the year 1 million pieces, yeah. But why should a parts manufacturer producing parts for planes, although the number of parts is not so many, why should they still automatize and go into serial production and think about their process technology? What is the reason behind this?
It's an excellent question, because there were some trials to ask automotive production people how to automate aircraft production, and they always failed because the number of parts, for example, obviously, and also the variation of parts, and so they failed. And the question is, why have they failed? Because today you can either automate, like the automotive industry did, or you don't. There's very not much in between, and this is where we step in, and we make automation more flexible. So if you want, we automate the automation, and that makes the effort to automate much lower. We try to reach, or to aim near zero effort to automate, and you do this with developing technology bricks that you can combine to always have the right degree of automation at any time. Because in 5 years you can probably automate more because you have new technologies and so on. So the whole production needs to be different than today. Today it's very rigid. In the future it has to be much more flexible. And this is more or less what we do here. So we enable automation for aeronautics.
Yeah. So your customers, Michael, are the component manufacturers of airplanes, or are you serving the plane manufacturers direct? So in which tier
both.
are you? Both. Okay. So both are your clients. Yeah.
So
okay.
It's OEMs, mainly Airbus, of course, and tier 1 suppliers, mainly Premium Aerotech and Airbus Aerostructures, but also others like MT Aerospace, for example, is also an Airbus supplier, but not a tier 1 supplier. So we don't stop at tier 1. We go also lower, but main and also Airbus helicopters, not to forget. So mainly it's the OEMs and tier 1 suppliers, but we would like a lot to work much more with tier 2, tier 3, and small and medium-sized companies.
So let's form a call to action now to the community. Anyone who is a material specialist and wants to go into component manufacturing and wants to establish process technologies, please make sure to contact Michael. Michael, you are on LinkedIn, I've seen. We are also connected anyway. So can they contact you on LinkedIn right away? Or yeah. Okay, so easy going. Contact Michael and talk to him about this fantastic process technologies. Michael, let me ask you about what Christoph Lieske said, Lufthansa Technik, before about this this comparison between carbon, glass, and these flux fibers. Now, from a process standpoint, industrialization. Now, we know natural fibers are not as exact, not as consistent. There is a natural grown fiber. So, first of all, are you processing? Also, do you have equipment to process natural fibers? Or what would you recommend to anyone who is thinking in natural fibers?
Well, I think the main challenge you have already addressed, and this is that natural grown fibers are not as constant in their properties as industrially produced materials and fibers. The good thing is that if we learn how to deal with natural grown fibers, so with the variable input to have a constant output, and this is due to a process control, then we can use it also for industrial manufactured materials, because then we can relax the requirements, and then we can save costs and very often also resources, because to produce a very constant output, usually you need a lot of resources. Maybe you have some scrap then due to the requirements. So this is the main challenge, and we are working on it. We have a kind of network here in Augsburg, which deals with artificial intelligence in production processes. And this is exactly the goal, to enable a variable input and a constant output. And this is done with a lot of sensor technology during the process, and with a lot of control technology, and also AI where it helps.
So you've given the Stichwort, the bullet point AI, and this is where now my friend Alexander comes into play. And after this very short break, I will also ask Christoph about his experience. I have an idea, and I want to discuss this idea with you guys. See you in a moment, Michael.
Thank you.
So, Alexander.
Ilkay, hi.
Herzlich willkommen. Welcome back to our show. First of all, thank you so much for bringing us the engineering talks to the community, to the LinkedIn community. I've been at your headquarters in Selb this week and already posted about it. So NETZSCH Group is a very reputable company. Alexander, he's the CTO of sensXPERT, and we're working now for quite a few months now together on making composites even more attractive and more more known in the markets, and this engineering talks serves the purpose of getting you closer to composites. Now, composites in the past was your material science, and now to the science comes also the data science. Alexander, now Michael talked about he would require some AI in order to, get out of the weakness or overcome the weakness of natural fibers. Christoph from Lufthansa Technik, he talked about that natural fibers produce less CO2 in the whole lifetime. So natural fibers are coming into the play. But before we talk about these natural fibers thing, and I'm curious to know your opinion on this matter, can you explain us shortly what is the innovation and the technology that sensXPERT is giving to this community to enhance quality and production efficiency?
For sure. Yeah, thank you, Ilkay. And before I relate to what Michael and Christoph have mentioned, what we are doing with sensXPERT is we try to resolve one brick of the entire manufacturing challenge we have when it comes to more sustainability and reducing the CO2 footprint. What we are in principle doing is we make the hidden potential in material. Here we talk about the resins visible with all the deviations, even when it comes to the flux fibers with varying humidity content and stuff. That is what we can make visible. That is what we can react to. And we make, and that is what Michael said very great in his words, we bring more flexibility to manufacturing. And we are resolving one brick. So we are really looking into curing crystallization of resins of the material based on all deviations that can occur. And we bridge the gap in between material science coming from the material, the real material and component behavior during production. And we do that with artificial intelligence. So we bring together machine parameters, material science, and the real material behavior together in machine learning environments to bridge the gap and to really make the material behavior obvious and visible, and being able to react to the material behavior and the differentiation and to control then the process based on the material behavior. So that is what we do as sensXPERT, where we try to help our customers to get more insights into the production and to make use of the hidden potential that is within the material and not visible today.
Wonderful. Let me screen the comments. So I'm seeing Oliver is on the way to Porta Westfalica. Do you know where Porta Westfalica is?
No, I wanted to ask you.
Oliver, please let us know where is Porta Westfalica. Also Westfalen, I know, yeah, but Porta. Okay, anyway, maybe it's an insider. Then we had. I need to check this with LinkedIn. Daphne.
All right.
She's saying hello from Friedrichshafen, Lake Constance. Oh, wonderful place, of course. Yeah. And Daphne is asking also a question on non-destructive. We will show that in a moment. And then we had also Sylvia from Luxembourg. So we have quite a good range today. So please, community, keep on asking your questions, keep on sending your comments. We have organized this meeting for 60 minutes, but we will be probably taking a little longer, maybe 10 minutes more to wrap this up. And continue with Alexander now. Alexander, you had with sensXPERT, you have this project sensXPERT, which is a corporate venture of the NETZSCH Group. You have this for a couple of years going on, and you were responsible with the process intelligence to start this off. And one of your first projects, if not the first, I don't know, is with Airbus. Can you tell us about what you have managed with Airbus?
For sure. Yeah, what is maybe interesting for the community, I was working at the Fraunhofer Institute that is next to Michael's building at the DLR in Augsburg. So I even grew up in Augsburg and studied there. And in 2016, I joined the NETZSCH Group with a strategic focus to take a measurement technology from the laboratory and to use material science in production to enhance our people on the shop floor there. And in 2016, when I joined NETZSCH, there was a project started already in early 2016 to enhance the manufacturing capabilities of Airbus in Spain. And here we started a very close collaboration with NETZSCH, so the Spanish entity of Testia, an Airbus company that is taking care about production efficiency, trying out new stuff, new sensor technologies, enhancing productivity based on component design, a lot of different things. So coming from the design to automation, they are doing everything. And everything they do and that is getting approved is then taken via the R&D team of Airbus into the manufacturing environment and then tested there as well. And we started in 2016 with a measurement technology based on the dielectric measurement principle that is capable of measuring the material behavior on the microscopic level in real time, but gives us the possibility to measure the degree of cure, glass transition temperature, degree of crystallization, flow behavior, aging effects in real time during production. But back in 2016, it was a pure measurement technology. And our job was to translate the information the sensors create into the valuable benefits. So into exactly what I mentioned, degree of cure, glass transition temperature and stuff that Airbus and NETZSCH can really make use of and benefit from. And that was the time where we screened the technology environment that is available on the market. And we said, okay, look, we now have a measurement technology. We have a lot of knowledge around this measurement technology, but we need to transform it into a real solution for automation. And therefore, so we started in 2016 together with Airbus, made a lot of trials, and we translated by hand. So really, we were sitting in front of our PCs, analyzing the data, translating it into the reference values we got from the laboratory. And that was a great hint that we are moving into the right direction, but the problem still was, it was a lot of manual work. It was not 100% objective. So we as humans could do some of the errors there, but we had a good progress and we could validate that everything goes into the right direction. But then there was a point in 2019, we have within the NETZSCH Group a so-called digital sounding board. It's like Shark Tank, where you can pitch your ideas in front of the shareholders and managing directors of the NETZSCH companies. And here I presented the idea behind sensXPERT. So combining the measurement technology with artificial intelligence and create a new team around what means a lot of different competencies we need, from electronics development, from software development, cloud development, data science, applications. So to bring a lot of people with core competencies together and to let them really develop the solution coming from the lab technology into a manufacturing solution for automation. And we got the first okay in September 19. Then in 2020, during Corona, during the first year, we were building up the minimum viable product. But as you all know, during Corona, we were not allowed to enter the shop floor and to try all the things out we have agreed on, also with Airbus. So even they have shut down the facility and nobody was allowed to enter because this is the beating heart of earning money for Airbus at the end. So we had some delays, but we still have been in contact and we have worked further and made a great progress. And then there was a point where we did a validation with Airbus that in real time during manufacturing of carbon fiber components based on thermosets in the aviation industry, what we measured in real time during production met the requirements of Airbus that they qualified in post-process laboratory measurements on the components, but we could do it in real time. So we could then do the quality control in real time, and we could shorten the cycle times a lot while ensuring the quality. And that was exactly the target of Airbus, to shorten cycle times. So to make a cost down measure of the production. Here we are talking about the Airbus A350 series. And yeah, that is the way we went on. And yeah, since 2022, our technology is being used within the series manufacturing there.
Okay, congratulations. Very good. The A350 is, I think, by weight, 50% in composites. So is your technology used in many, many components, or is it a certain area? You say Spain. I know Spain is producing the Leitwerk, the vertical, or the Seitenruder and things like that. So it's more on the wing side.
You know, since I mean, the aviation industry is very conservative, and it's okay that it is the way because we're talking about a high security level in there. So we are working with Airbus and NCR together at one specific component right now. So they are using our technology for one specific component. I mean, you saw from 2016 to 2022, it has been some time to get implemented in the series manufacturing, and it will take another time to be implemented and widespread then in other processes as well. But since we are in there, we are working together with NCR on different projects, different future upcoming projects where even there the technology is being tested and it's tried out if our technology fulfills all the requirements that are needed. And if so, then it's widespread from one to the next technology, and then from 2 to 4, 5, so whatever. But this takes some time, and that's okay. We're happy to be in this position because it's not that easy to enter the series manufacturing in the aviation industry.
Aerospace is a marathon. It's not a sprint. Aerospace is for sure a marathon. And everyone who is, I see Michael is also not. So we are talking here 10 years, 20 years Zeiträume, time horizons. So it's great that you have your foot in the door and that Airbus is picking up these latest technologies. And then from now on, part by part, it certainly has a chance and opportunity where it makes sense to apply this technology. But Alexander, critics say that in quality management, I'm quoting critics, we got our measurements from the laboratory. We have material cards. Why should I make the effort to apply AI? What would you say to these critics?
I can say, let's try to make 4 parameter variations and try to get a clear picture of all the dependencies there. Because this is even, and that is what we do in our daily life, we always try to relate one thing to another. But as soon as the complexity comes to a level where, and I mean, 4 parameter variations doesn't look that much, or doesn't sound that much, but we as humans, we are not capable of dealing with a lot of different dependencies and to connect it and to know, to build up the relationships between parameter variations and at the end, quality indicators and component costs. And that is exactly where AI has a big strength, because AI has the capability to take into account a lot of different parameters and their variations. And if I do the fundamental studies first in a very good way, then the AI can learn all the dependencies and behaviors, and then they can reduce. And we have a use case like that with 40 parameter variations. AI is capable of reducing that complexity into a 3-dimensional visual plot that we as humans can then understand again, and where we can then learn from and say, okay, this is now what I need to do and what I have to do to be in the right process window again. And this is simply not possible with our brains. Here we as humans are restricted in following all the dependencies there.
Yeah, I'm glad you mentioned these interdependencies, from variable to variable, and you have so many variables which can then stipulate the quality. So I think, yes, AI is absolutely needed. In my view, this is a more interesting and legit case even than all these generative AIs where you make these fancy pictures and text. Everything has its place, yes, but getting AI into production and quality efficiency improvements, this is where the real money and potential and saving lies. So let me check one more time the comments because we are getting now into the noontime. So Paul is tuning in from Bielefeld, near Minden, Westfalen. Or is this the answer, like Oliver says, nearby Bielefeld, because we asked what is or where is Porta Westfalica? Anyway, so Stefan says, finally joined from Belgium. Welcome. Welcome, Stefan. So anyone who has tuned in at a later stage or who cannot tune in live, we are greeting also at this time our podcast guests, because you will listen to this on a podcast. You can watch this anytime you want. So it will be available on all our channels. And Alexander, I would like now to take the opportunity to get also Christoph and Michael one more time into the picture. Let's make a final round before we conclude this. So there's a fantastic view here. It's like in the TV, CNN. many people watching us. So Christoph, AI. What's your stance on AI? Do you need AI at Lufthansa Technik for your R&D?
Definitely, we have a lot of people working on that topic right now and trying to find ways to use it for us. It's not as simple because, as we know, the AI public available has their problems with knowledge that's not knowledge and getting information into AI. So we're working on a lot of topics in this area, but it's not my personal expertise right now. So we have other people working on that.
Okay. Alexander, from what Christoph said before regarding the hemp fibers, do you have any suggestion, any comment on hemp or flax fibers in the cabin?
Yeah, for sure. Because coming from an automotive use case, what we have observed is, especially with natural fibers, the humidity is deviating. So it's not just the stability of the fibers itself in terms of mechanical performance and dimensional stability, but even the humidity that is creating a lot of clouds during manufacturing. So that means all the metrics, the natural fibers are bedded in. The matrix behavior is depending on the humidity the fibers bring with them. And even there, you get a different cure crystallization behavior based on the humidity variation. And that is also something where we are in and where we are dealing with to make this deviation obvious and to help our customers here. In this case, first touch point was the automotive industry there, to get rid of the scrap production based on the variations, while just getting the insight and being able to react to that.
Christoph seems to agree.
Yes, I've heard about that problem. So yeah, it's known. But I will talk with some with our partners. Maybe find their solution and come back to you, Alexander.
Would be great, definitely. It's always worth to discuss.
Yeah.
Yes, Michael. You mentioned also AI. So is AI something that is on your core tasks for 2025?
Yes, where it helps, it is. So it's not the solution for everything, but it's an ingredient for overall solutions that is very, very helpful, sometimes necessary. And maybe one thing about the quality and non-destructive testing and so on, because it's part of the topic of today. AI can help to produce quality and know your quality without always testing your quality in the end, which is quite expensive. So you can increase your quality and increase your efficiency and decrease the testing effort that you have, and with AI and of course many other things. So yes, it's obviously it's part of our daily work since we are here. In earlier times we didn't mention AI, we just said solution. But of course today it's quite important sometimes to mention that it's AI based.
Alexander?
Yeah, I can totally agree, because that is exactly the path we see. And what I see for the future is a combination between measurements, sensors, simulation, and to bring all this together in AI models, because then we can reduce complexity, save a lot of time, and get to faster decisions then.
Yeah, and also for planning tasks and logistic tasks, and to make automation more flexible, as I already said. To ensure that if you have changes in your automated production, you always have to try to reduce the effort near zero.
Alexander, Christoph is asking, as AI usually has to learn prior getting results, and you've mentioned that also, how many tests do you usually need to get a solid database for learning on the interdependencies, and how does that relate to conventional test cycles? And that's a very legit question, because particularly in aerospace, you don't have so many parts to learn, do you?
Yeah. And that's exactly the point. Most people who think about AI and big data, they think about, oh, I need to implement something for months or years to collect enough data to make decisions based on that. But while combining domain knowledge in a very specific way and in the right way to go, so today you often find the wording physics-informed AI. So if you give AI the boundaries and you bring it from the beginning on into the direction what you're really doing, so that means really use case by use case and not having a universal model that you use for language models and manufacturing and stuff, because this is not working. But if you do that, and here I can give you direct numbers, we are able within the aviation industry, based on bridging the gap between laboratory results and material science that we put into our models, machine parameters, and the real material behavior and manufacturing, we have seen that based on 15 components that have been manufactured in the exact same way with some small deviations that occur naturally, we are capable of creating the first machine learning model that creates benefits in a financial way for our customers. And then with every single component that comes on top, we create additional information that is then fed into the machine learning models that will continuously be retrained.
Okay, wonderful. So I think we've covered now everything that is mentioned in the comments. Thank you, community, for your comments and all your questions. Very, very interesting. And I really love it that we have this subject matter experts here. You've seen the brightest minds of our industry of aviation is here. And yeah, let me come to the end of the story of our engineering talks. So we have covered aviation quality and efficiency in the production of aviation and aerospace parts. We have covered with Lufthansa Technik mainly the natural fiber side, which was very interesting. Thank you for Christoph, who had also a very interesting last 24 hours. Yeah, if you have missed that part, go back to the beginning and watch it in replay. Michael, thank you so much for giving us the opportunity to have a look into your DLR Augsburg setup. Yeah, Alexander, also thank you for highlighting always the technological process and progress with getting AI in order to improve the processes. Are you guys at all going to JEC World 2025?
For sure.
Yes. I'm not quite sure yet.
Christoph, not sure yet. Okay, so maybe we can meet there and have a family photo at JEC World 2025. Just a short comment why I'm bringing up the JEC World 2025. So we are right now Composites 360 on tour, planning our tour for Composites for the JEC World 2025. So besides and in addition to these engineering talks, we are also, of course, on site, and JEC World 2025 will be the next opportunity. And we will bring some companies into the spotlight. And if you want to be interviewed at JEC World or here in the engineering talks, then please, write me an email here on LinkedIn or contact me through WhatsApp, which you can find on my LinkedIn profile. These engineering talks, by the way, let me get everybody in one more time. These engineering talks, this was the first edition. It went very well about aviation. We've discovered many new aspects of composites, why they are attractive. And also, we will be continuing these engineering talks in January. We are going on the third week of January. It will be the 15th, 16th, or 17th of January. We are going live again, this time with infrastructure and construction. Infrastructure, we will be looking at trenchless technologies, and with construction, we will look into rebars. So that's our January program. And then in February, because JEC World is in March, we have even two engineering talks. Beginning of February, we will be talking about the sporting goods industry. Many people forget that the sporting goods industry is a high volume user of composites. So we will be talking probably about hockey sticks, about bikes, and this sort of fancy sporting stuff. And we will talk, of course, end of February with automotive experts, composites in automotives. So if you want a seat in our panel, please talk to us and we are glad to check the availability and the story that you can provide to our communities. So that's it from my side. Michael, let's do a final round of call to action, CTA, which is typical for social media. What should people do now after they have watched this engineering talk, in your view, in your mind?
Yeah, think about what you would do if you could automate your production, and talk to us to find a solution how to do it, even if it seems to be impossible, because it's usually not. It's quite useful.
Okay, great CTA. Christoph, what's your CTA?
Oh, take on the challenge, I would say. Never hesitate, try new things, get better.
Absolutely. Do it. Just do it, like Nike said.
Yes.
Okay, Alexander, finally your side.
Yeah, think in ecosystems, reach out to everyone who can most probably help you, because it's always worth to have a chat.
Okay, wonderful. So thank you, dear community, for tuning in and watching this either live or on replay. I'm seeing always with one eye on my smartphone the attendance. It's great that you have been here. This is your last chance. Leave a comment here so that also the community sees you and can click on you and you can network. You know, this is important for the visibility. Write your comment here right now, either live or on the replay, so that we are getting this community activated. I thank you so much, Michael, one more time for being part of our show. It was very enjoyable. Christoph, thank you so much that you could make up the time. I really appreciate that. And Alexander, as always, my pleasure to have you here on our side and introducing many new modern technologies to the composites world. And community, see you next time then in January. Meanwhile, what can I say? Maybe it's a little too early, but Merry Christmas and Happy New Year to you guys.
Yeah,
bye.
Thank you, Michael. Thank you, Christoph. Thank you, Ilkay.
Bye.
Bye.
Construction and specialized technologies available to end users, as well as attract projects, customers, and talent. Join our Composites Lounge community. The Composites Lounge community is open to entrepreneurs, C-levels, specialists, and managers who want to create a better world with their innovative composites and play a key role in the success of their company. So if you're a hidden champion who isn't sure how to best promote your work, join a supportive and innovative community, which is focused on making composites achievements visible to end users. The Composites Lounge community celebrates and promotes the best innovations, lightweight construction technologies, and sustainable solutions in the automotive, aviation, renewable energy, oil and gas industries, and many more. Get involved at compositeslounge.com.